Potential at axial point of charge ring. Here it is a charge ring is placed vertically on the and a axis passing through the center of the ring, and we have to find the potential at point P on the axis at a distance x. So taking a elemental length of the ring, and the linear charge density is given lambda, and this distance, if the radius of ring is r, then this distance will be r equals to under root r square plus x square. So here dq will be lambda dl, and so potential at Vp integration dVp 1 by 4 pi epsilon naught dq by r square, or 1 by 4 pi epsilon naught integrating from 0 to L, 0 to 2 pi r, L is here 2 pi r, so lambda dl by under root r square plus x square equals to 1 by 4 pi epsilon naught lambda by under root r square plus x square into 2 pi r, or 1 by 4 pi epsilon naught lambda into 2 pi r will be equal to q, 1 by 4 pi epsilon naught q by under root r square plus x square. Case if x equals to 0, that is at the center of the circle, potential VO will be equal to 1 by 4 pi epsilon naught q by r. Potential at axial point of a charge disk. Here it is a charge disk, and we have to find potential on its axial point. It is placed in the plane of the paper, and we have to find like this potential at point perpendicular to the plane of paper, and axis passing through the center of the disk. The radius of disk is given r, and the surface charge density is sigma. So to calculate the potential, first we have to consider a ring at a distance x of thickness dx. So the charge of ring will be dq equal to sigma dA equal to sigma into 2 pi x dx. Now potential due to ring at point P will be dVp 1 by 4 pi epsilon naught dq by this and dq by under root r square plus x square we have calculated earlier. So 1 by 4 pi epsilon naught dq, putting the value of dq, sigma 2 pi x dx under root r square plus x square. So potential due to whole disk will be Vp integration dVp sigma into 2 pi 4 pi epsilon naught 0 to, because our first ring will be at here and the last ring will be at here. So integration will be from 0 to r, because here x is variable. So x dx under root x square plus r square. To solve this, put z equal to, so Vp equal to sigma 2 pi 4 pi epsilon naught integration 0 to r x dx by root under x square plus r square. To solve this integration, we have to take substitution methods. Z equal to x square plus r square. Or equals to, here given z is equal to x square plus r square when x is equal to z is equal to r square, and when x is equal to r, z is equal to r square. Now sigma by 2 epsilon naught integration of that will be z to the power 1 by 2, and the limit will be r square to r square plus r square. So we have sigma by 2 epsilon naught under root r square plus r square minus under root r square, or sigma by 2 epsilon naught under root r square plus r square minus r. Case at the center of the disk r equals to 0, since the potential will be sigma by 2 epsilon naught into r, or sigma r by 2 epsilon naught. Next, potential at the edge of the disk. Here a charge disk is shown, and we have to find the potential at any edge, any point on the edge, like this point, or another case may be like this point, anywhere on the circumference of the disk. So to calculate the potential at point P, let us divide the disk in a large number of arc rings with P as a center. This we have divided it into its arc ring, and or arc with P as a center. Then dq, if we consider this, dq will be sigma dA, and sigma into area of arc ring. So sigma into, in this case, area will be, this is R, and if this is L, then here theta equals to L by R, so L equal to R theta, so 2L will be 2R theta, and thickness is dr, so area will be 2R theta into dr. So dV will be 1 by 4 pi epsilon naught dq by r, or 1 by 4 pi epsilon naught sigma 2 r theta dr by r, or sigma by 2 pi epsilon naught into theta into dr. In this case here we see this is r and this is r, and if this is theta, we draw a perpendicular, then it will be r by 2, and this whole is 2l. Now cos theta will be, in this case, cos theta will be r by 2 by r, or r by 2r. So r will be equal to 2r cos theta, hence dr will be 2r into minus of sin theta d theta. So here sigma by 2 epsilon naught theta dr equals to sigma by 2 epsilon theta minus of 2r sin theta d theta, or minus of sigma by 2 pi epsilon naught 2r theta sin theta d theta. So v will be integration dv from pi by 2 to 0, because when the arc ring is at here, theta is 0, and when it is at here, theta is pi by 2. Or solving it, minus sigma by 2 pi 2r theta sin theta d theta, we get sigma r by pi epsilon naught, hence v equal to sigma r by pi epsilon naught. Next important point, as v equals to u by q, so delta v equal to delta u by q, or delta u equals to q into delta v. Also we know that delta u equals to delta w external, hence delta w external equals to q into delta v. Since delta w electrical is minus of delta w external, so equals to minus q into delta v, that is delta w electrical equal to minus q into delta v. Now the next problem will be based on these formulas. So here an example is given, that is the electric potential at point A is 20 volt and at B is minus 14 volt. Find the work done by an external force in moving an electron slowly from B to A. So we have delta W external Q to Q into delta V. Here delta V is means that final minus initial, so Vf minus Vi, and we are moving the charge from B to A at point A, and B to A means A is final and B is initial from B to A. So we have delta W external equal to Q into delta V, and the delta W external B to A worked in moving the charge from B to A equals to Q into VA, that is, this is final, A is final, so VA minus VB. Now we have given the charge value minus 1.6 into 10 to the power minus 19 coulomb, and electron has this charge, and final is 20 volt, and minus of initial is minus 40 volt. So we have minus 1.6 into 60 into 10 to the power 19 joule, or equals to minus 9.6 into 10 to the power 18 joule. So this is the work done by external agents. Now del W external is minus of del W electrical. This implies del W external B to A minus the del W electrical B to A. So del W electrical B to A minus to del W external B to A, or equals to minus of minus 9.6 into 10 to the power minus 18 joule equals to 9.6 into 10 to the power 18 joule. Answer. That is, work done by electrical force in moving the charge from B to A will be minus Q into VA minus VB, or Q into VB minus VB. Next is our problem. 12 joule of work has to be done against an existing electric field to take a charge of 0.01 coulomb from A to B. That is, initially A and finally is B. How much is the potential difference? Again, we can use the above formula. Delta W external equals to Q into delta V, because here external agent is working. So hence del W external A to B equals to Q into VB minus VA. Hence VB minus VA equal to del W external A to B divided by Q, or 12 by 0.01 equal to 1200 volt. Answer. Next. Find the work done by external force in moving a charge Q equals to 2 microcoulomb from infinity to a point where electric potential is 10 to the power 4 volt. Again, we can use del W. Here we have to calculate the work done by external force. So we should use the formula for external force, work done by external. The del W external is Q into delta V, or del W external infinity to P equals to Q into Vp minus V infinity. So Q into Vp, since V infinity is equal to 0, so 2 into 10 to the power minus 6 into 10 to the power 4 equal to 2 into 10 to the power minus 2 joule. Answer. Next, a charge Q equals to 10 microcoulomb is distributed uniformly over the circumference of a ring of radius 3 meter placed on XY plane with its center at origin. Find the electric potential at a point 0, 0, 4 meter. The situation is shown in here. The center is at the origin, that is, the charge ring is placed in the XY plane, and we have to find the potential at Z axis as shown in the figure at a distance of 4 meter. So we know the formula for finding the potential at the axis of ring. The potential due to ring at axis is Vp equal to 1 by 4 pi epsilon naught Q by under root R square plus Z square, where R is the radius of the circle. Now 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into Q is given 10 to 10 into 10 to the power minus 6, and under root 3 square plus 4 square, solving 9 into 10 to the power 4 by 5 equals to 1.8 10 to the power 4 volt. Next, Find out the points on the line joining two charge plus q and minus q kept at a distance 1 meter where electric potential is 0. Find out the points on the line joining two charge plus q and minus q kept at a distance of 1 meter apart where electric potential is 0. So it is also we can find using directly solving this. For it, let P be the point on the axis either to the left or to the right of charge plus q at a distance r where potential is 0, here plus q and minus q. In this case, it is on the left side of charge plus q, and in this case it is in the right side of charge q. And if this distance is given 1 and we are taking this distance as r, so and here also we taking the distance as r. Now since the potential should be 0 at p, so we have Vp will go 1 by 4 pi epsilon naught by r minus of 3q by 4 pi epsilon naught 1 plus r in this case equals to 0. This imply 1 by r minus 3 by 1 plus r equals to 0, or 1 by r equals to 3 by 1 plus r, or 1 plus r equal to 3r. This implies 2r equals to 1. Hence r equals to 0.5 meter. Again, for the next case, Vp equal to 1 by 4 pi epsilon naught q by 4 pi epsilon naught r minus of 3q by 4 pi epsilon naught 1 minus r equals to 0. So this implies 1 by r minus 3 by 1 minus r equal to 0, 1 by r equal to 3 by 1 minus r, or 1 minus r equal to 3, or 4r equal to 1. Hence r equals to 1 by 4, 0.25 meter. Thus the potential is 0, either 0.5 meter to the left or 0.25 meter to the right of the charge plus q. Next, relation between the electric potential and field. We have potential V equals to q by 4 pi epsilon naught r and E equals to q by 4 pi epsilon naught r square at a distance r from the charge, or equals to E equals to 1 by E equals to V by r, because q by 4 pi epsilon naught r is equal to V, so V by r, that is E equals to V by r. In differential form, since V equal to 1 by 4 pi epsilon naught q by r, differentiating with respect to r, dV by dr equals to minus 1 by 4 pi epsilon naught q by r square, and equals to minus E. Hence E equals to minus dV by dr. In vector form, dV equals to minus of E vector dot dr vector, or integration of dV equals to minus of integration E vector dot dr vector. Now in projection form we can write Ex equal to minus of del V by del x, Ey equal to minus of del V by del y, and Ez equal to minus of del V by del z. And now E vector equal to Ex I cap plus Ey j cap plus Ez k cap. So equals to minus of del V by del x into I cap minus of del V by del y into j cap minus of del V by del z into k. When this is written as minus of del y del x I cap plus del y j cap plus del y del z k cap into V, or E vector equal to minus of gradient V or it is written as del operator. It is a del operator whose value is given by this formula. Del vector equal to del y del x into I cap plus del y into j cap plus del y del z into k cap, and is called del operator. And it is at E vector equal to minus of gradient V vector. You can also read as. Now polar form. Here it is shown, this is a distance r, then and consider this arc length is dl and this distance is dy. Then we can write dl equals to r d theta, or delta l equals to r into del theta. If x is very small, that is if theta is very small, then delta l equivalent to delta y, that is equal to delta y. Hence delta y will be r into delta theta. So Ex will be minus del v by del x, and hence Er will be minus del v by del r. So and Ey will be minus del v by del y, minus del v by del y. This imply in y direction we have theta, so E theta equals to minus del v by r into del theta, because del y is equal to r del theta. So E theta will be minus del v by r del theta. So Er and so we can write Er equals to minus del v by del r. Here x is equivalent to r, so we are using this formula, because Ex equal to minus del v by del x. So x is in the along the r direction, so we are writing it Er equals to minus del v by del r, and y is equivalent to theta direction, so we are writing Ey equals to minus del v by del y equal to E theta equals to minus del v by r del theta. So Er equals to minus del v by del r, and E theta equals to minus 1 by r del v by del theta. Next, find electric field if potential is given by A equals to A into V equals to A into x square minus y square, B V equal to axy. So the solution of A, B have Ex equal to minus del v by del x. So minus del by del x under bracket A into under bracket x square minus a square equals to minus a into 2x, or equals to minus 2ax, and Ey equals to minus of del v by del y. So minus of del v by del y minus of del by del y under bracket A into x square minus y square, or minus of a into 0 minus 2y, or 2 into ay. Hence E vector will be Ex into Ex I cap plus Ey j cap minus of 2x into I cap plus 2ay j cap, and mode of E vector will be under root 2x square plus 2ay square, or 2a into under root x square plus y square. Next, given V equal to axy, so we can calculate Ex equal to minus del v by del x minus del v by del x ax into y, or minus of ay, or Ey equal to minus del v by del y. So minus of del y del y into axy equals to minus of ax. Hence E vector will be equal to Ex into I cap plus Ey into j cap minus of ay I cap plus minus of ax j cap, or minus of ay I cap minus ax into j cap. So mode of E will be, that is magnitude, under root minus of ay to the whole square plus a square of minus ax, or a into under root x square plus a square y square. So this is the value calculated.